Hello there, and welcome to the Sleepy Space Channel. The universe runs on a small and quiet set of rules, and scattered across it are objects that seem to defy every one of them. There is a world darker than coal, that gives back almost none of the light that falls upon it. There is a planet where the rain is molten glass, blown sideways on winds faster than sound. There is a single star wide enough to swallow the orbit of a ringed giant, and there are galaxies that trail long glowing tails behind them, like creatures of the sea. There is even a wall of galaxies so large that our best understanding says it should not exist. Tonight, we gather the strangest of them together and walk slowly through the whole quiet catalogue of the universe's anomalies. If you find these slow journeys through space worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is anything you need to hold on to. These are far-off places, and they ask nothing of you tonight. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade quietly away behind you. Let's begin. The universe is a place of rules. Gravity pulls, light travels, heat spreads outward, and worlds turn in the patient arithmetic of orbits that has held for billions of years. And yet those same rules, followed into their stranger corners, produce objects that seem as though they ought not to be allowed. There are worlds where it rains stone. There are planets with no star at all, drifting alone in the dark. There are single stars wide enough to swallow the orbit of a giant planet whole. Tonight, we travel among these quiet anomalies, the worlds and stars and galaxies that do not behave the way the ordinary pattern would predict. None of them breaks the laws of nature. Each of them is those laws, carried all the way out to a strange and distant place. An anomaly, in the sense we mean tonight, is not a mystery in the supernatural sense. It is simply an object that stands outside the expected. To notice one, you first have to know what the ordinary looks like. And so we begin not with the strangest world, but with the most familiar kind, the search for another Earth, a second quiet world, where a sea might lie under an open sky. Once that ordinary world is clear in the mind, everything unusual that follows will stand out against it, the way a single lit window stands out along a darkened street. Astronomers measure how Earth-like a world is on a simple scale, with our own planet set as the standard and given the value of 1. The scale gathers together a few plain facts about a world, its width, its density, and the temperature at its surface, and folds them into a single number. A world close to 1 is close to home. A world far below it is something else entirely, too hot, too cold, too heavy, or made mostly of gas. By this measure, the great majority of the worlds we have found score low. They are giants of hydrogen and helium, or scorched rock, or frozen stone far from any warmth. Being nearly Earth-sized is not enough on its own. A world can match our planet almost exactly in width and mass, and still be a hostile place. One of our nearest neighbors in the sky is a near twin of Earth in size, and yet it sits beneath a heavy, smothering atmosphere, so close to its star that its surface runs hot enough to melt soft metals. Size alone tells you little. What matters is the whole arrangement, the star, the distance, the air, the light, and how those pieces happen to fall together. It helps to sort the worlds we have found into a few broad kinds. At one end are the worlds that resemble Earth, hardly at all the giants of gas, and the scorched or frozen rocks, worlds where a single measurement runs so far past the comfortable range that nothing else can redeem them. In the middle are the worlds that resemble ours, more closely rocky, moderate in temperature, some of them perhaps carrying water, a promising but uncertain company. And at the far end, closest to the ideal, sit only a small handful of worlds whose size and warmth place them very near the standard of home. The near-Earth world we are coming to belongs to that last, rare group. But even the highest score is only an invitation, never a promise. A world can sit squarely in the comfortable range and still be unfit for anything living. A world too light cannot hold a thick atmosphere. Its air leaks slowly away into space, and without air there is no shelter and no warmth kept close. A world with a weak magnetic field lies open to the radiation of its star, which can strip an atmosphere away over ages and scour whatever lies beneath. A world held with one face to its star may freeze solid on its night side and bake on its day, unless winds or seas can carry the heat around. Earth-likeness, measured from a distance, tells us where to look. It does not tell us what we will find. That uncertainty is part of why the search moves so slowly. We cannot visit these worlds. We can only read them from far off, in the faint marks they leave on their star's light, and reason out the rest. A great deal of patient watching goes into establishing that a single small world is even there, and more still into estimating its size, its weight, and the temperature it might hold. Every world on tonight's tour was assembled this way, from Whispers and the near-Earth world. The gentlest anomaly of all was among the hardest one of them. When all of those pieces do fall together well, the result can be arresting. The most Earth-like world found so far orbits a small, dim, red star, a little over 12 light-years from here. In cosmic terms, that is close, almost neighborly. And yet the star itself is so faint that no eye on Earth could ever pick it out of the dark without a telescope. It holds only a small fraction of the sun's mass, and it burns far cooler and redder, so the narrow ring of comfortable warmth around it lies very close in, far nearer than our own world sits to the sun. Circling within that ring is a world only slightly heavier than Earth, and very nearly the same width. From those two facts, a great deal follows. Its surface gravity is likely close to what we know. Its inside is likely built the way ours is built, a core of metal, a thick mantle of rock, and a thin crust of hardened stone laid over the top. When the numbers are gathered and the models are run, they place its average temperature within a gentle band, the kind of band in which liquid water could rest on the surface rather than boiling away or freezing solid. Of all the worlds catalogued beyond our own system, this one sits nearest to the quiet ideal of home. But even here, at the most Earth-like world we know, the first hint of anomaly appears. Worlds this close to a small, cool star tend to become locked in place, held so firmly by the star's pull that they keep one face turned toward it forever. On such a world there is no sunrise and no sunset. One hemisphere lives in endless day, baked under a red sun that never moves. The other lives in endless night, turned always toward the cold. Between them runs a permanent band of twilight, a ring of perpetual dawn where the light lies low and level and never climbs. There is a second complication, and it belongs to the star. Small red stars are not always steady. They flare, brightening sharply and briefly, throwing out sudden floods of light and radiation before settling again. A world held close would feel each of those flares pass over it. For life as we understand it, that flickering, restless star would be a difficult star to live beside, generous with warmth one moment, harsh the next. And yet even these problems carry their own quiet answers. A world with a genuine ocean could soften both of them at once. Water is patient with heat. It gathers warmth on the day side and carries it around toward the night in slow currents. evening out the difference between the two faces. And water is a shield. Its upper layers can absorb the worst of a star's radiation, so that beneath the surface, in the calm below, the flares fade to nothing. On a locked and flaring world, the safest place would be the sea, and the most likely place, if anything ever stirred there, would be the sea as well. This near-Earth world does not travel alone. It shares its dim star with at least one sibling, a second world set a little farther out, beyond the edge of the comfortable ring. That outer world receives far less warmth, and its surface likely runs well below freezing across most of its face. Even so, it need not be entirely locked in ice. Beneath a thick outer shell, warmed from within, a hidden sea of salt water could lie in the dark, in the same way that the frozen moons of our own outer giants are thought to carry oceans sealed under their crusts. So the little red star holds two worlds at once, one that might hold water on its surface, and one that might hide it below. It is worth pausing on how faint the traces are that reveal such worlds. A planet like this gives off almost no light of its own. Against the glare of even a dim star, it is all but invisible. We do not see these worlds directly. We find them instead by the small effects they have on the star they circle. A world tugs on its star as it orbits, and the star answers with a tiny wobble, drifting toward us and away again in a slow, regular rhythm that its light quietly records. A world crossing in front of its star, if the alignment is right, dims that star by the faintest fraction as it passes. From those whispers, a wobble of a few meters, a dimming of a fraction of a percent, the size and the mass and the orbit of an unseen world can be drawn out. Nearly everything we will say tonight about distant worlds was learned this way. From starlight, read with great patience rather than from any picture. Worlds like this near-Earth pair are not rare. Small red stars are the most common stars in the galaxy, far outnumbering suns like ours, and many of them carry rocky worlds in close, quick orbits. If life has any foothold in the wider universe, a great deal of it may sit exactly here, on locked worlds beneath unmoving red suns, in oceans that never see a proper dawn. There is a strange comfort in the thought. The most ordinary kind of world in the universe may not be a world like Earth at all, but a world of endless twilight. Its brightest country, the thin ring of perpetual dusk, where the red light lies flat along the ground and the shadows never shorten. Stand for a moment, in the mind, in that ring of dusk. The star hangs fixed on the horizon, swollen and dim and the color of a dying coal. It does not rise and it does not set, it simply remains. Behind you the land falls away into permanent night and hardening frost. Ahead of you it climbs toward a desert of unending afternoon. And here, along the seam between them, the temperature is mild, the light is low and gold red, and a sea laps at a shore that has never known a morning. It is not Earth, but it is not nothing either. It is one of the quieter ways a world can be, and against it, the louder anomalies begin to show. This is the pattern we will follow all night. We take an object, we set it against the ordinary, and we let the difference show. The most Earth-like world we have found is already a little strange, a planet of endless day and endless night, circling a star too dim to see, kept livable, if it is livable at all, by an ocean we cannot yet confirm. It is the gentlest anomaly on the tour, and the closest to home. From here, the worlds only grow stranger, because for every world that keeps a quiet balance, there are many that do not. There are worlds where the seasons refuse to stay in one place, and worlds that fall toward their stars like comets and race away again, and worlds so close to one another that they trade earthquakes across the dark. The rules that make a calm world are the very same rules that make a violent one. It is only the arrangement that changes the distance, the tilt, the company a world happens to keep. And so we turn now from the world that looks almost like home to the worlds whose skies have gone strange, where it is not the ground that unsettles a visitor, but the motion of the heavens themselves. On most worlds, the sky is the steady part. The ground may shift and the weather may turn, but the pattern overhead, the round of days, the slow march of seasons, repeats with a reliability you can set a life by. The worlds we come to now are different. On these, it is the sky that has gone strange. Their surfaces may be ordinary rock. It is the motion around the star, the shape and tilt of the orbit itself, that turns the climate into something no calendar could hold. Consider first a giant world that circles not one star, but two. Its pair of suns move around each other in a tight, quick dance, and the world tracks around them both from farther out. That alone is not so unusual. What makes this world an anomaly is the way its orbit will not hold still. The pull of two moving stars, rather than one steady sun, keeps tilting the plane the world travels in. Slowly, over years, the whole orbit nods, like a coin spun on a table that wobbles as it turns. Because of that wobble, the world's path across the sky, as seen from far away, keeps changing. For a stretch of time it passes squarely in front of its stars, crossing their faces and dimming them in a way we can measure. Then the tilt carries it out of line, and for years it crosses nothing at all, slipping above or below the stars from our point of view and vanishing from the record entirely. A world that was plainly there, counted and measured, simply stops appearing not because it has gone anywhere, but because the angle of its wandering orbit has quietly changed. Then, after a long silence, it returns. The same wobble that hides the world from us reshapes its weather from within. As the orbit tilts, the part of the world that receives the most direct light does not stay at the equator, where a planet's warmest band usually sits. Instead, it slides from the equator toward the poles and back again over the long rhythm of the wobble. The seasons, in other words, do not stay in their places. The zone of strongest sun migrates across the face of the world, and the whole pattern of warm and cold drifts with it. Models of such a world fill it with storms, on a scale we have no match for at home, turning systems larger than the greatest long-lived storm on the largest planet in our own system, carrying clouds of ice on winds that move kilometers with every second. It is a world where the sky itself is never quite finished arranging. The view from its clouds, if any eye could stand there, would be stranger still. Two suns would share the sky, close together and unequal, rising and setting not quite in step, so that shadows would sometimes double and sometimes fold into one. Over the long wobble of the years, the height of those suns at noon would climb and fall in a way no single season could explain. Where a warm belt sat one year, a cooler one would settle the next, as the region of strongest light slid slowly toward a pole and then eased back toward the middle. It would be less a world of 4 seasons than a world of one enormous, slow tide of warmth, sweeping up and down the planet across more years than a short life could count. And through all of it, the great banks of ice cloud would gather and stream and pull apart, never settling into the fixed weather patterns that a steady sky allows. From a world whose seasons wander, we turn to a world that falls. Another giant follows an orbit that is not the gentle near circle most planets keep, but a long, drawn-out ellipse, a stretched loop that carries it far out into the cold and then flings it in close to its star before slinging it out again. At the far end of that loop, the world drifts through a chill, where it receives about as much warmth as Earth receives from the sun. If it had moons, their skies might be mild and their surfaces even temperate for a time. But this peace does not last. The world is always falling inward, gathering speed, and the plunge toward the star takes only a matter of days. At the near end of the loop, the world whips around its star at close range, and in those hours, everything changes. The flood of energy it receives can climb several hundredfold within days. The temperature of its outer air can roughly double in a matter of hours, rising from a warm 500 degrees to well over 1,000 as it rounds the star. Heat arrives faster than the atmosphere can spread it, and the air blooms outward in waves, expanding so quickly that shock fronts race around the planet. Then the world swings away again, back out into the cold, cooling as it goes, until the next fall begins. It is a world with a single season of fire that lasts only a handful of hours. Once each long orbit, a comet's life lived by a planet, all rush and retreat. An orbit as stretched as this one rarely happens on its own. A world is generally born onto a gentle, near-circular path, and it takes something forceful to draw that path out into so long a loop. Most often, the cause is a neighbor, a passing star that swings near the system and warps its orbits, or a heavy sibling world whose pull, over long ages, works a smaller world's orbit into an ever more lopsided shape. In this world's case, the disturbance seems to have been strong enough that the system around it was left disordered and its birth material scattered, so the comet world may travel largely alone, with few companions to keep it company on its long fall and its long climb. There is a strange calm at the far end of its loop, worth pausing on before we leave it. For most of its orbit, the greater part of its time, the world drifts through the cold outer reach of its system, far from its star, taking in only a mild warmth. If it holds any moons, their skies during that long season might be gentle, their surfaces cool and quiet under a small, distant sun. A traveler arriving then would find nothing to hint at what is coming. Only slowly, as the world began its fall, would the star swell in the sky, and the light grow harsh, and the few hours of fire draw near. Then, just as quickly, it would all recede again, and the long, cold peace would return. It is a world of one brief, fierce summer, and a very long, still winter, on a rhythm too slow and too extreme for any single visit to take in. These bent and stretched orbits also show how delicate the balance of a calm system is. A world's path is shaped not only by its star, but by every other world around it, each pulling gently on all the others, without pause. Where those pulls happen to fall into a steadying rhythm, a system can hold for ages. Where they do not, orbits slowly wind tighter or looser, tilt and stretch, until a world that began on a mild round path finds itself on one of these severe loops instead. Nothing had to be broken to make it so. The same patient gravity that keeps our own world steady is the gravity that, elsewhere, drew these worlds out onto their strange and lonely paths. Both of those worlds are shaped by a single distant star. But an orbit can be bent just as strangely by a neighbor. In another system, two worlds share space so tightly that they come close enough to trouble one another directly. One is a rocky world, larger than Earth. The other is a small world of gas. Every few months, their paths bring them near, and at the nearest point, only a couple of million kilometers separate them, far closer than any two planets in our own system ever come to each other. Two worlds that near are not indifferent neighbors. They pull on one another with real force. At each close pass, the pull between them climbs many times higher than the moon's pull on the Earth. On the rocky world, That repeated tug is thought to flex and strain the whole crust. The ground rises and falls, the stone cracks, and in the strain, enormous eruptions may break loose. Some regions of that world may never fully settle between one encounter and the next, holding open seas of glowing molten rock while they wait for the next pass to knead them again. The rocky world may itself be a kind of survivor, perhaps the stripped inner core of a world that was once a gas giant, its lighter outer layers long since torn away, leaving a heavy body of iron and rock circling on. Its small gas neighbor is no calmer for the encounters. Wrapped in a thick shell of light gases over a solid center, it too is pulled and reshaped at every pass, and the two worlds trade their disturbances back and forth like a slow conversation neither can end. A system this tightly wound does not hold a fixed pattern for long. The orbits shift a little with each meeting, the paths drift and tangle, and over long spans, the whole arrangement behaves in a way that cannot be predicted far ahead. Careful models suggest that over many millions of years, the two worlds may eventually come too close and meet a single quiet collision that would scatter their substance into a ring of debris circling the star. It has not happened yet, and it will not happen soon. But it is written faintly into the geometry, the way a river's course already carries, somewhere in it, the shape of the sea it has not yet reached. Elsewhere, the same mutual pull that unsettles some systems instead locks others into a strange and lasting order. In certain families of worlds, the orbits fall into simple whole number rhythms, one world circling its star, twice, for every single circuit of the next, or 3 times for every 2, so that the worlds return to the same arrangement again and again, meeting at the same points, tugging one another in a pattern that repeats without end. A system tuned this way behaves almost like a piece of music, each world a note struck at a fixed interval, the whole ringing in a chord that holds for ages. These resonant chains are delicate. A single hard disturbance can knock a world out of step and set the pattern slowly unraveling. But where they hold, they are among the most orderly things in the sky, worlds keeping time with one another, so precisely that their whole arrangement could be written down as a rhythm, a quiet mechanism of orbits ticking in step around a distant star. It is the other face of the same coin we have been turning all along. The very pulls that drive some worlds into disorder can, in the right proportion, hold others in a patient and repeating grace. What unites these worlds is a single quiet idea. The anomaly is not always in the stone underfoot. Sometimes it is in the rhythm in the orbit that tilts or stretches or crowds too near another. An orbit is a clock, and on these worlds, the clock drives the weather directly, winding the seasons out of their places, lighting a few hours of fire in a long, cold year, or cracking a crust open twice a season with the passing of a neighbor. Set any of them beside the calm, near-circular path our own world keeps, and you begin to see how much of Earth's steadiness we owe simply to the shape of the loop it travels, and to the wide, empty distances it keeps from everything else. There is a gentleness in remembering that. Our orbit is nearly round. Our nearest neighbors keep their distance. Our seasons return to the same places each year because the geometry that carries us holds so patiently still. The worlds with impossible skies are not being punished. They are only following the same laws we follow, along paths that happen to be less kind. And having seen how strange a world can become while still circling a star, we can turn now to a stranger case, still to the worlds whose surfaces are the anomaly, where the ground is not solid in the way we mean it, and the rain is made of things that are stone and metal and glass at home. Until now, the strangeness has lived in the sky in the orbit, the tilt, the company a world keeps. We come now to worlds where the strangeness has soaked all the way down into the ground. On these, the surface itself is the anomaly. The rock does not stay rock. The rain is not water. And the weather is built from materials that, on Earth, we keep locked safely in the solid dark beneath our feet. Begin with the worlds of fire. One rocky world circles so near its star that its dayside has melted. Where Earth has continents and seas, this world has an ocean of molten rock, glowing and turning, reaching temperatures around 3,000 degrees. Its air is not air as we would know it. So close to that heat, stone itself evaporates, and the atmosphere over the dayside is made of vaporized rock and metal, a thin sky of the same material as the ground, lifted into gas by the fire below. That rock vapor sky does not stay still. Because the world keeps one face toward its star, the dayside bakes while the night side freezes, and the difference drives winds of extraordinary speed. Across the line between day and night, the vaporized rock streams faster than the speed of sound. And when it crosses into the cold, it does what any vapor does when it chills. It condenses and falls. On this world, that means a rain of stone. Droplets of rock form high in the sky over the night side and fall to the ground, gathering into rivers of lava that run slowly back toward the dayside, where the heat lifts them into vapor once more. It is a full weather cycle, complete and self-contained evaporation, cloud, rain, and return, except that every part of it is made of molten rock instead of water. Hotter still is a giant world whose dayside glows at around 4,000 degrees, a temperature that outshines the surfaces of many true stars. At that heat, the ordinary molecules of an atmosphere cannot hold together. They are pulled apart into their separate atoms, and metals that would be solid at home rise as vapor into the air. The star's fierce light is slowly stripping the world, blowing a faint tail of gas off into space behind it. Over long ages, this world is evaporating, a planet being gently unmade by the star it circles, shedding itself into the dark one thin stream at a time. It is not being destroyed in any hurry. It is simply, patiently, coming undone. From worlds of fire, we turn to a world of darkness. Among all the planets we have found, one gas giant is the darkest. It swallows more than 99 parts in 100 of the light that falls upon it, reflecting back almost nothing at all darker than coal, darker than fresh road tar, one of the least reflective objects known. What makes it so dark is not fully settled. Its air is scorching, and it seems nearly cloudless, and somewhere in it are substances that drink light rather than return it. And yet the world is not truly invisible. It is hot enough to glow faintly from its own heat, a dull ember red, like a coal that has stopped flaming but still holds its warmth. You would not find this world by its reflection, the way we see the moon. You would find it only by that low red glow, a world that gives back none of its star's light and shines, weakly, with its own. Near the worlds of fire and dark lies a world of an altogether more beautiful color and a stranger rain. It is a giant world of a color close to cobalt, a rounded drop of blue hanging near its star. On Earth, a blue world would suggest water and oceans and sky. Here, it suggests nothing of the kind. The blue comes from a fine haze of tiny particles suspended in the atmosphere, particles of silicate, which is to say, particles of glass. And the world's winds are quick, moving near 2 kilometers with every second, several times faster than the speed of sound at home. Caught on those winds, the glassy particles do not fall gently. They blow sideways, driven flat across the sky in a permanent, glittering, horizontal storm. It is a world whose color would be lovely, from a great distance, and unsurvivable, up close, a blue planet, where the rain is glass, and it never falls, only flies. The glass rain world is not the only place where the weather is made of minerals. On some hot giant worlds, the clouds themselves may be built of substances we would set in rings and crowns. Where the air runs hot enough to carry aluminum and its compounds as vapor, those vapors can gather high up into clouds of corundum, the mineral that, tinted by traces of other elements, we know as sapphire and as ruby. On such a world it may, in a sense, cloud over with gemstone, and any rain that fell from those clouds would be a fine bright dust of the same. Elsewhere, on the cold night sides of certain worlds, it may be metal that condenses and falls iron gathering out of the air as it chills, settling as a slow metallic snow onto ground that never sees a sunrise. The ingredients are ordinary to the universe. It is only the temperatures that make them behave in ways no earthly weather ever could. There are worlds, too, where the anomaly is simply that the weather never rests. On some, a thick atmosphere and relentless heating drive a storm that wraps the whole planet without pause, a single permanent tempest, with no calm season and no quiet hemisphere, the air always moving, always carrying dust or cloud lifted from the surface below. Such a world would hold no clear sky anywhere in its history, and no still day anywhere in its future. Only the endless turning of one storm that began before anything could have marked its beginning, and will not settle within any span worth the counting. The winds need not be violent in the way a passing squall is violent. They are simply constant a weather that is less an event than a condition, wrapped around the world like a second, restless skin. To stand on such a world, if standing were possible, would be to understand at once that the storm was older than any mountain and would outlast any shore, and that the quiet we take for granted, the plain gift of a windless afternoon, is itself a kind of fortune that many worlds are never given. Return, though, to water, because water has its own strangeness once there is enough of it. On the great ocean world, the sea does not simply grow colder and darker with depth, as ours does. It grows heavier, and at last, it changes its nature altogether. Under enough weight, water is forced into forms of ice, unlike any we keep in a glass, dense, exotic ices that form only under crushing pressure and stay solid even while hot. There may be more than one such layer, each a different form of pressed ice, stacked one beneath the next toward the core. The floor of that ocean is not sand or stone, but a shell of warm, heavy ice, sealing in a center of rock and metal far below. It is a world where you could sink for hundreds of kilometers through warm water and arrive, at the bottom, not at a shore, but at a surface of ice that is warm to the touch and harder than stone. If fire and glass seem far from home, water may feel like a return, but even water becomes strange when there is enough of it. Some worlds are made of water almost all the way down. One warm world, several times the mass of Earth, hides beneath a thick atmosphere of steam, an ocean far greater than any on our planet, not miles down, but hundreds of kilometers. And at the bottom of an ocean that immense, the pressure grows so extreme that water can no longer stay liquid, even while it is hot. Squeezed hard enough, it turns solid, not into ordinary ice, but into an exotic, heavy form of ice that stays firm at high temperature and sinks rather than floats. The floor of that ocean is made of this hot, pressure-formed ice, a smooth shell of it wrapped around a core of rock and metal far below. It is a world where the sea has a bottom made of warm ice and no dry land anywhere above. Not all ocean worlds are warm. Others hold their seas in the cold, sealed away beneath a thick lid of ordinary ice. On these, the surface is frozen hard, but far below, warmed by the slow heat of the world's own interior and the flexing of tides, a liquid sea can still turn in the dark. We know this pattern already, closer to home. Several of the icy moons that circle the giant planets of our own system are thought to carry such hidden oceans, black and silent, under crusts of ice many kilometers thick. A world does not need a nearby sun to keep an ocean. It needs only warmth from within, and a lid to hold that warmth in. And then there are worlds whose strangeness is written into their very chemistry. One world, larger than Earth and locked with a permanent molten face toward its star, may have formed from more carbon than our own planet ever held. Under its surface, at tremendous pressure, that carbon could take familiar and unfamiliar forms at once. Thick layers of graphite, the soft grey substance of pencil leads, and below them, pressed harder, layers of diamond. It is a world that may carry a fortune of jewels in its mantle, hidden forever beneath a surface of glowing lava and a sky of rock vapor. The riches are real and utterly unreachable, sealed under fire, valuable to no one, shining in the dark for no eye at all. What ties these worlds together is a single quiet lesson about materials. Stone, metal, glass, water, carbon, the same substances that make our own calm world, are here lifted into vapor, flung on the wind, frozen under pressure, or pressed into gems, simply because the temperature and the weight are different. There is nothing alien in the ingredients. Earth holds all of them too. It is only that our world keeps its rock as rock and its water as water, holding each thing in its familiar place. On these worlds, the same ingredients are merely arranged by a fiercer hand. And having seen how strange a world can be while still bound to a star, we turn now to the strangest homelessness of all, to the worlds that have no star, to circle and drift through the dark alone. Every world we have visited so far has belonged to a star. It has had a sun to circle, a source of warmth and light, an anchor holding it in place. The worlds we come to now have none of these. They are the wanderers' free-floating worlds, drifting through the dark between the stars, bound to nothing at all. They give off almost no light of their own, and they answer to no sun. Of all the anomalies in the sky, these homeless worlds may be the hardest to find, and among the strangest to hold in the mind, because they ask us to imagine a planet with no day, no year, and no star anywhere in its sky. A world can become a wanderer in more than one way. Most often, it is thrown out. In the crowded early life of a planetary system, worlds jostle and pull at one another, and a close approach to a larger sibling can act like a slingshot, flinging a smaller world clean out of the system and into the open dark. A passing star, drifting too near, can do the same, tugging a world loose from its orbit and setting it adrift. Once cast out, such a world carries the memory of its birthplace in its makeup, but never returns to it. It simply leaves, and keeps leaving, forever. There is a second path, quieter than the first. A world may never have had a star to lose. In the same cold clouds where stars are born, small knots of gas sometimes gather and collapse on their own knots, too slight ever to grow hot enough to catch fire as a star. What forms instead is a lone, dim body, made the way a star is made but falling short of starlight. Such an object is born already alone, drifting from the beginning, a world that was never anyone's planet. Whether flung out or born apart, the wanderers all share the same condition in the end. A world in the dark, going its own way. It is worth trying to picture a surface like that, though the mind resists it. there is no sun in the sky, and so there is no day and no proper night, only a permanent, dark, unbroken by any near star, lit at most by the faint, distant grains of the whole galaxy's other suns, far too remote to warm anything. There are no seasons, because seasons are a gift of circling a star, and this world circles nothing. There is no year to keep. The ground, whatever it is made of, lies under a cold so complete that gases we think of as air on other worlds would settle onto it as frost. And this condition does not hold for an age and then pass. It holds, for most of these worlds, effectively forever billions of years of the same silent dark, the same slow loss of the last inner warmth, with nothing to mark the passing of the time but the very gradual cooling of the world itself. It is the longest and quietest kind of existence the universe allows a world to have. The nearest wanderer we have confirmed lies only a few light-years from here, and it is bitterly cold. Its temperature is low enough that water gathers into clouds within its air, a world with weather of a kind, but no sun to drive it. In size and makeup, it resembles a cooled-down giant, a body of gas that has been quietly shedding its warmth for a very long time. What heat it has does not come from any star. It is the leftover warmth of its own formation, the slow release of heat from a body still gently settling and contracting under its own weight. It glows, faintly, in the way embers glow after the fire is out, not from any new flame, but from the memory of an old one. That leftover warmth turns out to matter more than it might seem. A world can hold its inner heat for an astonishingly long time if it is well wrapped. A thick atmosphere is a good blanket, so is a lid of ice. And a wanderer with a hot interior beneath such a covering could, in principle, keep an ocean of liquid water turning in total darkness, a sea warmed entirely from below, with no sky worth the name above it. If such a world carried a moon out of its old system, the flexing of tides between them could add still more warmth, kneading the interior and holding the sea liquid across ages. It is one of the more haunting possibilities in all of this, that the dark between the stars may be scattered with lightless oceans, sealed under ice, kept warm by nothing but the slow heat of the worlds that hold them. We are only beginning to learn how many of these worlds there are, and the early counts are large. The galaxy may hold enormous numbers of free-floating worlds, very possibly in the billions, perhaps rivaling or even outnumbering the stars themselves. If that estimate holds, then the space between the stars is not as empty as it looks. It may be quietly crowded with worlds, each one dark, each one alone, drifting between the bright points we can see. The lit stars would then be the exceptions, and the true majority of worlds would be these unseen wanderers, passing through the night unnoticed. Finding them at all is a delicate art, because a world that gives off no light cannot be seen in the ordinary way. The usual method relies on a brief trick of gravity. Now and then, a wanderer drifts almost exactly between us and a distant background star. As it passes, its gravity bends and gathers the star's light, and for a short while, that background star appears to brighten, then fade, as the invisible world slides across the line of sight. The world itself is never seen. Only its mass leaves a mark, a slow flare of another star's light, rising and falling over days or weeks. From that single flicker, the presence of an unlit world can be read out of the dark. It is a way of finding something by the shape of the shadow it does not quite cast. There is honest disagreement about even what to call these worlds. The largest of them shade upward toward the dim, failed stars we will meet a little later, and where a world ends and a failed star begins is not a line anyone can draw cleanly. Some prefer to call the smallest free-floating bodies simply worlds without stars. Others give them longer, more careful names, unsure whether to file them with the planets or with the almost stars. The disagreement is not really a sign of confusion. It is a sign of how gently one kind of object gives way to the next. Out here, how the universe, again and again, declines to sort itself into the boxes we bring to it. What is not in doubt is how many there may be. If the early counts hold, the wanderers are not a rare curiosity, but a common feature of the galaxy, present in numbers to rival the stars themselves. That changes how one pictures the space between the stars. We tend to imagine that space as empty, a clean, dark gulf with the occasional star burning in it. But if the wanderers are as many as they seem, then those gulfs are quietly populated, threaded with dark worlds drifting between the lit ones, unseen and uncounted, each going its own slow way. The night between the stars may be less a void than a slow, dark migration. And the strangest possibility of all is that some of these lightless worlds may not be barren. A wanderer with a warm interior and a heavy blanket of air or a thick lid of ice could hold an ocean liquid for an astonishingly long time, warmed entirely from within. In such a sea, sealed under ice and lit by nothing, the plain ingredients for a slow chemistry would still be present: warmth, water, minerals, and time in great supply. Whether anything could ever stir there we cannot say, and may never learn. A lightless world adrift between the stars is very nearly unreachable, and very hard to read from afar. But the mere possibility is a quiet marvel that life, if it were hardy enough, might not even require a sun, but only warmth from below, and patience, and the long dark to hold it. We have spoken of these wanderers before, on an earlier night, given over to the worlds without a sun. What is worth adding here is only how ordinary they may turn out to be. We are used to thinking of a planet as something that belongs to a star, held in a tidy orbit, warmed and lit. But that may be the special case, not the rule. Across the whole galaxy, the common fate of a world may simply be to drift cast loose early, or born loose, and then set free to wander for a very long time. For the fate of a wanderer is a long one. Most of these worlds will never be captured by a new star. The chance of drifting close enough to be caught and slow enough to be held is very small. Instead, they will travel on through the cold for ages, slowly giving up the last of their inner warmth, growing colder and darker with the eons. Some, in the far future, may fall inward toward the center of the galaxy, or be swallowed in some distant collision, or simply cool until they are all but frozen through. They carry no passengers we know of, keep no time anyone would recognize, and arrive nowhere in particular. And yet there is a strange peace in them. A wanderer asks nothing and disturbs nothing. It moves through the dark on its own quiet errand, a world at rest in the fullest sense, no sunrise to wake to, no season to mark, only the long, even drift through a night that does not end. From these worlds that belong to no one, we turn now to worlds that have belonged and lost the survivors, and the strange places where a world can still be found circling the dead. Some worlds are strange, not for what they are made of, but for what they have lived through, or for the company they keep. These are the survivors and the aftermaths worlds that endured the death of a star, worlds wrapped in rings beyond all proportion, and worlds found circling the burned-out remnants of suns that died long ago. To reach them, we have to remember that stars do not last forever, and that when a star ends, the worlds around it do not always end with it. Consider first a world that lived through its star's old age. When a star like the sun grows old, it does not simply fade. It swells, Its outer layers billow outward until it becomes a red giant, a bloated star, hundreds of times its former width, its surface reaching far enough to engulf the worlds that once circled close. Any inner world would seem certain to be swallowed and destroyed. And yet, around one such aged star, a giant world remains. As the star ballooned outward, its swelling layers grew so thin and so faint that they nearly brushed the planet's orbit, and still the world came through. It endured the long reach of the dying star, and before the fire could unmake it, the star shed those outer layers into space and shrank down to a small, dense, glowing remnant. Now the survivor circles that remnant, a world that passed through the furnace of its star's death and lived to keep orbiting the ember left behind. How a world comes through such an ordeal is itself worth a thought. As a star swells and then sheds its outer layers, it loses a great deal of its mass, and a lighter star holds its worlds less tightly. The orbits loosen and drift outward in answer. A world that would have been swallowed by the star's earlier, fuller reach may find its own orbit carried outward just far enough and just in time to survive the worst of the swelling. It is a narrow escape written in slow motion. Over many thousands of years, the star reaching for the world as the world quietly backs away, the two of them running a race whose outcome was settled by the finest of margins. Not every world is so fortunate, and the dead stars themselves keep the record of those that were not. When a star like the Sun finishes shedding its layers, what remains is a small, dense, cooling remnant. And around many such remnants, we find the crushed evidence of worlds that did not escape. The remnant's light carries the chemical marks of rock and metal settling onto it. The ground-up substance of planets and smaller bodies, pulled apart and drawn in, sprinkled across the surface of the dead star. These are stars that consumed their own worlds, and now wear the traces of them in their light. To read one of these dead stars closely is to read a quiet list of the worlds it once held and has since taken back. From a survivor of fire, we turn to a world dressed in something no other world can match. One young giant, a body so large it hovers at the boundary between a heavy planet and a failed star, is circled by a system of rings so enormous it makes the finest ringed planet in our own sky seem modest. The familiar rings we know at home would fit, comfortably, within the space between the Earth and the Moon. This world's rings would fill the space of an entire planet's orbit, a set of concentric arcs, spreading hundreds of times wider than any rings near home, sheet upon sheet of dust and debris, turning around the central world. Within those rings, there is a clue that something is being built. A clean gap runs through the disk, a lane swept, nearly empty of material. The simplest explanation for such a gap is a moon, a new world forming inside the rings, gathering the debris of its lane and clearing a path as it grows. If that reading is right, then in those distant rings, we may be watching a moon being born, assembling itself out of the disk around a world that is itself barely finished forming. Rings on this scale do not last. Over long ages, they will thin and settle. Some of their material will spiral inward and fall onto the central world, and some will be flung away entirely. What we see is a passing splendor, a young world briefly crowned, in the middle of making at least one moon of its own. The sight from a world within that ring system would be like nothing in our own sky. Set on the surface of a moon circling the giant, one would look up to find the central world filling a great span of the heavens, many times wider than our full moon, a soft glowing face hanging almost fixed above the horizon. And spread across the sky, from one edge to the other, the rings would arc in bright bands of light, sheet upon sheet of them, turning the night into a pale silvered twilight rather than a true dark. There would be no black night at all on such a moon, only the steady glow of the giant and the long, luminous curves of its rings, dividing the sky from side to side. It would be lovely past describing, and it would not last. On the slow clock of such systems, the rings are a passing ornament, and the moon that watched them would, in time, look up to a sky quietly emptying of light as the great disk thinned and settled and fell away. The strangest addresses of all, though, belong to worlds that circle the dead. When certain stars end their lives, they do not fade into embers but collapse into something small and fierce, a remnant only a handful of kilometers across, spinning many times every second, sweeping the space around it with beams of radiation like a lighthouse turning in the dark. It would seem the least likely place in the universe to find a planet. And yet the very first worlds ever discovered beyond our own sun were found here, circling exactly such a remnant. They almost certainly did not survive the catastrophe that made it. They were built afterward, gathered from the ring of debris the dying star left behind a second generation of worlds, assembled from the wreckage, circling the corpse of the star that could never have been their parent. Around that turning lighthouse, they endure a steady sleet of radiation, sweeping over them with every rotation, on worlds that formed in the aftermath of an ending. What those worlds must be like is hard to picture and worth the trying. They circle a spinning remnant no wider than a small city, which sweeps its beams across them many times every second, so that their skies would flicker with a rhythm faster than a beating pulse. They receive little ordinary warmth, for the remnant gives off scarcely any gentle light. What reaches them instead is radiation, steady and searching. And yet they hold their orbits, patient and exact, circling the corpse of the star with the same faithful regularity that any world keeps around any sun. It was that very regularity that gave them away. The spinning remnant is one of the finest natural clocks in the universe, its beats arriving with extraordinary precision, and the tiny rhythmic disturbances in that clock, as unseen worlds tugged the remnant first one way and then the other, were what first revealed them. The first worlds ever found beyond our own sun were found not by their light, which is none, but by the way they nudged the ticking of a dead star's clock. Near this idea sits one of the most quietly astonishing worlds we know. Around another such collapsed remnant circles a world that may be, in effect, a single enormous crystal. It appears to be a body of carbon planet-sized and squeezed under such extreme pressure that the carbon has taken a crystalline form throughout. In plain terms, it may be a world of diamond or something very near it, the compressed leftover core of a companion star that was stripped down over ages until only its dense carbon center remained. It does not sparkle. It is not a jewel in any sense a hand could hold. But it is a world's worth of crystallized carbon, turning in the dark around a dead star, formed not by any gentle process, but by the slow, patient crushing of what was once a star into what is now, essentially, a gem the size of a planet. There is a thread running through all of these worlds, and it is worth naming softly. A star's death is not always an ending for everything around it. Sometimes a world survives the swelling and the fire. Sometimes new worlds are gathered from the debris of the old. Sometimes what is left behind is pressed into a form stranger and more durable than anything that came before. The universe is not tidy about its endings. It reuses, rebuilds, and repurposes. The wreckage of one thing becomes the substance of the next. A world can outlive its sun. A moon can be born in the ruins of a disk. A dead star can gather a family of worlds it never made. Endings, out here, are rarely the last word. And that thought carries us naturally toward the stars themselves, for we have spoken of stars swelling, dying, collapsing, and leaving remnants behind, always as the background against which these worlds live and end. It is time to turn the tour toward the stars, directly, and to the anomalies among them, the largest, the hottest, the strangest behaved of all the suns. For if the worlds can be this unusual, the stars that make and unmake them can be stranger still. We have spoken of worlds and of the stars they circle as though the two were plainly different things. A planet on one side, a star on the other, a clear line between them. But the universe does not always honor that line. Between the smallest stars and the largest planets lies a whole population of objects that are neither and belong fully to neither category. They are the in-between things, bodies too large to be called planets and too small to shine as true stars. To meet them is to watch one of our tidiest distinctions quietly dissolve. To see why they exist, it helps to remember how a star catches fire. A star is born when a knot of gas in a cold cloud collapses under its own weight, growing hotter and denser at the center as it shrinks. If enough material gathers, the core reaches the pressure and the heat at which hydrogen begins to fuse, and the object ignites a self-sustaining fire that will burn for millions or billions of years. That is a star. But there is a threshold below which this never happens. If the collapsing knot is too light below a certain fraction of the smallest ordinary stars, the core never quite reaches the conditions for a lasting fire. It grows warm. It glows. But it never truly ignites. What forms instead is one of these in-between bodies, a failed star, if you like, though there is nothing like failure in it. It is simply a body that gathered enough substance to begin the journey toward starhood and stopped short. It shines dimly, mostly in the low, warm light that lies below what the eye can see, and its glow comes not from any steady fire, but from the heat of its own making, slowly leaking away over ages. Because that light is so faint and so red, these bodies are among the hardest to find. They hide easily against the dark, and are best seen not with ordinary sight, but with instruments tuned to warmth rather than to visible light, which can pick out a dim, cooling body that the eye would never catch. For a long time, these bodies were expected before they were ever seen. The reasoning was simple enough. If it takes a certain least amount of material to light a star, then nature, which is rarely tidy about its edges, ought to make a great many bodies that fall just short, and those bodies ought to exist, glowing dimly, waiting to be found. For years, the prediction stood without proof, because the objects were too faint and too cool to catch with the instruments of the time. Only when we learned to look in warmth, rather than in visible light, did they begin to appear, one after another, exactly where the reasoning had placed them. There is a particular satisfaction in that kind of discovery. Not stumbling upon something unlooked for, but finding, at last, a thing you had good reason to believe was there all along. The failed stars were a promise the universe had made in theory, and then, quietly, kept. One arrangement of these objects shows how close they come to being stars, and how a small accident of history decides the matter. In one system, 3 of these failed stars circle together 2 larger ones, close beside each other, and a third, smaller and colder, orbiting far out. They appear to have formed from a single cloud of gas and dust that broke, early on, into 3 separate clumps, rather than gathering into one. And here is the quiet astonishment. Had that cloud not split, its combined material would have been enough to cross the threshold and light a true star. The difference between a star and these three dim bodies, was nothing more than whether the original cloud stayed whole or came apart. One accident of splitting turned a single star that might have been into three failed stars that are. Their skies are stranger than their story. The atmospheres of these bodies hold the substances we might expect in a cool world water and simple carbon compounds, but they hold something else as well. High in the air of some of them are clouds made of minerals, fine particles of silicate, the stuff of sand and glass and stone, floating as haze and gathering into cloud banks. On these bodies it can, in a sense, cloud over with rock. The weather is mineral. And where there are mineral clouds, there may be mineral rain droplets of what would be sand or glass at home, condensing high up and settling slowly through a warm, thick sky. It is a kind of weather with no counterpart on any world we know, born of the fact that these bodies are hot enough to carry stone as vapor and cool enough to let it gather again into cloud. At the cold end of this population, the line grows blurriest of all. The smallest and coolest of these failed stars approach the temperatures of ordinary planets. Set one of them beside a large, warm, free-floating world, and it becomes genuinely difficult to say which is which. One was a planet that never had a star. The other was a star that never caught fire. And in the middle, where they meet, the two descriptions overlap so completely that the labels stop meaning much. There is even honest disagreement about what to call the smallest of them, whether they belong with the failed stars or with the giant worlds, and that disagreement is not a failure of knowledge, so much as a sign that the universe simply did not build a fence where we wanted one. These bodies have weather, too, which is among the more unexpected things about them. Because they are not lit from outside by any nearby sun, but glow instead with their own fading warmth, and because they turn often quickly, they develop bands and storms across their faces, much as the giant planets of our own system do. Some appear to be marked with enormous, long-lived storms. Some show spots that come and go. Some seem patchy, with breaks in their mineral clouds through which warmer, brighter material shows from below. As one of these bodies turns, its brightness can flicker in a regular rhythm, betraying great cloud systems rolling in and out of view. They are not featureless embers. They are turning worlds with skies of their own, complete with fronts and clearings and slow, banded storms of stone. At the very coldest end, some of these bodies come down to temperatures we would find almost ordinary. The chilliest of the failed stars are no hotter than a warm room, and in their upper air, water gathers into clouds much as it does in the sky of Earth, clouds of plain water vapor floating over a body that was very nearly a star. It is a peculiar thing to hold in the mind, an object born of the same collapse that lights the suns, and yet cool enough that one could, in principle, stand near it unburned, its sky hung with water clouds, its glow so dim and red as to be almost no light at all. These are the gentlest of the in-between things, and the closest of them, in the end, to the cold, dark worlds we met among the wanderers. And many of these in-between bodies are wanderers themselves, bound to no star at all. Just as some worlds drift free of any sun, so do some of these failed stars, floating alone through the same dark between the suns, glowing faintly with their own leftover heat and answering to nothing. In the full census of the galaxy, then, there is no clean shelf where the free-floating worlds end and the free-floating failed stars begin. The two populations shade into one another and drift together through the same night. It is one more place where a line we drew turns out to be a slope. The galaxy is not divided into the lit and the unlit, the star and the world, as neatly as our words suggest. It is filled instead, from the faint red stars down through these dim in-between bodies to the cold, dark worlds, with a smooth and quiet gradation of things each a little less like a star and a little more like a world than the last, all the way down to the frozen wanderers in the dark. That, in the end, is the anomaly of these in-between things. It is not any single body among them. It is the whole idea of them, the discovery that our neat division of the sky into stars and planets was always a convenience, and that reality fills the gap between the two with a quiet, abundant population of objects that honor neither name. The smallest stars shade downward into these dim bodies. These dim bodies shade downward into the largest planets, and there is no sharp step anywhere along the way, only a smooth slope from the things that burn to the things that merely glow, to the things that are simply cold. There is something steadying in that, once the surprise of it settles. We draw lines because lines help us think, and the universe is under no obligation to draw them where we do. Between the faint red stars and the great dark worlds is a continuous band of bodies, each a little larger or smaller, a little warmer or cooler than the last, filling in the space we imagined was empty. The failed stars are not a flaw in the order of things. They are the order of things, seen without our categories, a reminder that the sky is a spectrum and not a set of boxes. And carrying that thought with us, we can turn back toward the bodies that did catch fire, and to the stars that push even that fire to its limits, the largest, the hottest, and the most restless suns of all. Stars are usually the steady, reliable fires of the sky, the fixed points against which everything else drifts. But stars, too, have their anomalies, and they live at the edges of size, of heat, and of behavior. Some are so large they defy easy imagining. Some are so hot they strip themselves apart. And some are so restless that they wrap themselves in their own shed substance, hiding behind a shell of their own making. To understand them, we only need to remember that a star is a balance, a fire, pushing outward against a weight, pulling inward, and that this balance can be struck in some very strange places. Begin with size. One red supergiant stands as a candidate for the largest star yet measured. Its scale is difficult to hold in the mind, so let us set it where we can measure it, in the place of our own sun. Were this star to replace the sun, its glowing surface would not stop at the inner worlds. It would reach outward past them, past the middle of the system, out toward the orbit of a great ringed planet, swallowing everything within. Light, which crosses the whole inner region of our system in a matter of minutes, would take hours merely to travel once around this single star. It is a fire so wide that its own light needs the better part of a day to circle it. And yet, for all that size, the star is astonishingly thin. Spread across so enormous a volume, its material is stretched to a wispiness thinner than the air we breathe. A star you could, in the outer layers, pass a hand through and scarcely feel. It is immense and tenuous at once, more a glowing atmosphere the size of a planetary system than a solid ball of fire. Its true dimensions remain uncertain. Stars this large and this unsteady are hard to measure exactly, and their outer edges are soft and shifting. But even the modest end of the estimates leaves it among the largest single objects in the sky. A star grows to such a size only near the end of its life. Through most of its years, a star burns hydrogen quietly in its core and holds a steady shape. But when the core's first fuel runs low, the balance shifts. The star swells, its outer layers billowing outward and cooling as they spread, until the surface glows the low red of embers rather than the white of a young sun. Inside, the fire moves on to heavier fuels, fusing the ashes of one stage into the fuel of the next. A star this large is living fast and near its end, and its future is written already. In time, it will collapse and rebound in a great outpouring of light, scattering its outer layers into space and leaving behind a small, dense remnant, a core wound down to stillness or squeezed into something stranger. This was not always the star we call the largest. Before it, the title belonged to another swollen red giant, itself wide enough to reach past the orbits of the inner worlds if set in the sun's place, and there are several more that crowd close behind, all of them enormous, all of them uncertain, all of them near the ends of their lives. The very largest stars are the hardest to pin down because their outer layers are so thin and so restless that where the star ends and its shared atmosphere begins becomes a matter of judgment. What is certain is that a small handful of stars are so large that our whole inner system would be lost inside them without a trace. That ending, when it comes, is among the largest single events the universe produces. For a short while, the dying of one such star can pour out more light than a whole galaxy of ordinary suns, and in that outpouring, elements heavier than the star could ever forge in its steady life are made and scattered into space, some of the very substances that will one day gather into new worlds. What remains at the center is a small, dense remnant, a spinning ball only a handful of kilometers across, or, if the star was heavy enough, something denser still, a point around which even light must bend, and from which it cannot return. The larger stars carry their endings openly, in their swollen and unsteady shapes. To look at one is to look at a fire already by the slow clock of the stars, very near its close. From the largest star, we turn to one of the most restless. Another dying giant has taken to shedding itself. It is a carbon star, a swollen, aging sun, whose fires have laced its outer layers with soot, and it is throwing that material off into space at a great rate, wrapping itself in an expanding shell of dust and gas. That shell has grown enormous, spreading tens of thousands of times wider than the distance from the Earth to the Sun, and it is not smooth. It is layered and pocketed, threaded with arcs and half-formed rings, the record of a star that pulses and breathes as it dies, releasing its substance in gusts rather than a steady stream. From outside, the star itself is nearly hidden, buried in the soot it has made, glowing through its own smoke. There is a puzzle wrapped in that shell. Within the hot gas around this sooty, carbon-laden star, observers found water vapor, which should not have been there at all. A star of this kind was thought to bind up all its oxygen into other compounds, leaving none free to make water. The most likely answer is a subtle one. Starlight, splitting apart molecules in the thinner gaps of the shell, frees oxygen atoms that then join with hydrogen in the heat, and water forms where none was expected. It is a small mystery, quietly solved, and a good reminder that even a dying star can still surprise the people watching it. There is a gift hidden in that shedding too. The soot and dust this star is casting into space do not simply scatter and vanish. They drift outward and join the thin material that lies between the stars, enriching it with carbon and with grains of solid matter, the very stuff from which new worlds are later built. The carbon in a future planet's crust, the dark grains that will one day gather into rock, may well pass first through a dying star like this one, made in its interior and breathed out into the dark on its slow, sooty wind. In losing itself, the star sows the ground for what comes after. Its ending is also a kind of scattering of seed, and the worlds that gather long afterward, in some far cloud, will carry a little of it in their substance, without ever knowing the star it came from. Then there is heat taken to its limit. Among the hottest stars known is a rare, bare stellar core near the very end of its life. Its surface burns many tens of times hotter than the surface of the sun, so fierce and so luminous that its own outflowing wind tears away an Earth's worth of material every few months. A star like this has already blown its outer layers off entirely, leaving the blazing core exposed to open space. It is a fire with its skin removed, shining with a violence that will not last long. Before very long, in the reckoning of stars, it will collapse and end in a great burst, seeding the space around it with the heavy elements forged in its final agonies. Around such a stripped, blazing star, there often hangs a shell of its own shed gas, lit and made to glow by the fierce radiation pouring off the exposed core. The star's wind sweeps that gas outward and shapes it, so that the whole is wrapped in a faint, structured envelope of glowing material arches and shells and streamers, all held in place by the ceaseless outward push of light and wind. From a distance, the star would seem to sit at the center of a soft, luminous bubble of its own making, a fire that has thrown off its outer garments and now shines within the glowing remains of them. Stars like this are among the rarest we know, and among the shortest lived. The exposed core stage lasts only a brief while in the reckoning of the stars, a final, brilliant chapter measured in a span that is, by their slow standards, hardly more than a held breath before the end. It is worth pausing on that heat because it points to something the cold cannot match. Cold has a flaw, a lowest possible temperature, a point past which nothing can go colder. But heat has no such ceiling. The newborn cores of collapsed stars can flash, for an instant, to temperatures beyond any furnace. The first moment of the universe itself was hotter still. And yet there is a highest temperature that physics can even describe, a point so extreme that the familiar laws blur and lose their footing, and beyond which our understanding simply runs out. That is perhaps the strangest thing about heat. It does not stop at a wall the way cold does. It stops instead at the edge of what can be said about it, running out of describable room long before it runs out of nerve. What all these stars share is a single role, and it softens their strangeness into something almost tender. Stars are the forges of the universe. Inside them, the light elements, left over from the beginning, are fused into heavier ones, the carbon of living things, the oxygen of the air and the seas, the iron at the center of our own world. The largest star, thin and swollen, the sooty star, hidden in its own smoke, the bare hot core, stripping itself in the dark. Each is a furnace at some stage of its work, and each, in ending, scatters what it has made into space, where it will one day gather into new stars and new worlds. The anomalies among the stars are not accidents. They are the extreme moments in a long, patient labor, the making of the very substances from which everything else, ourselves included, is eventually built. And that labor is nowhere more visible than in the great clouds where the whole cycle begins again, the nurseries where new stars are still being lit, one dim point at a time. Not every anomaly is a single point of light. Some are enormous clouds, the nurseries where stars are made, spanning many light years, holding thousands of young suns in the act of being born. The nearest of the great ones is close enough to see without any instrument at all. On a clear winter night, below the three bright stars that form the belt of a familiar figure, there hangs a soft smudge of light. That smudge is a cloud of gas and dust, wide enough to hold a small city of stars, and inside it, right now, new suns are lighting one by one. Within such a cloud, the making of a star is a slow act of gathering. Gravity draws the gas together into knots, and each knot, as it collapses, grows hotter and denser at its center, until at last it kindles into a star. The nearest nursery holds thousands of stars already lit, and a few thousand more still forming, all packed into a region a couple of dozen light-years across. Because they have all condensed from the same cloud, these stars are close kin, born at nearly the same time, made of nearly the same material, a single family of suns gathered in one place. To look into the cloud is to see stars at every stage of their earliest life at once, from the barely begun to the newly shining. At the bright center of the nursery sits a tight knot of young, heavy stars, the most massive of which is the ruler of the whole cloud. That great star pours out so much light that it illuminates the gas for light years around, and its fierce wind pushes the nearby material away, carving out a clearing around itself. The cloud glows because of stars like this one, lit from within by the very suns it is making, so that the gas shines in soft curtains and folds of colored light, brightest where the young stars are hottest and most crowded. Scattered through that glowing gas are darker, smaller things that matter just as much. Around many of the youngest stars are dense, dark disks of gas and dust, flattened rings of material circling the new suns. These are the beginnings of worlds. Within such disks, over long ages, dust gathers into grains, grains into pebbles, and pebbles into planets. To see one of these dark disks silhouetted against the bright cloud is to see a planetary system caught at its very first moment, before a single world has formed the raw material of future planets, still gathered around a star that itself is barely finished. The young stars do not form quietly. As a new sun takes shape, it often flings out narrow jets of gas from its poles, and where those jets slam into the surrounding cloud, they light up glowing knots and arcs and ribbons of shocked material. These are among the few things in the sky that visibly change over a human lifetime. Over mere decades, they shift shape, brighten, and fade as the young star breathes and settles. Faster still are compact clots of gas that punch outward through the cloud like slow shot fired into fog, dragging long, glowing wakes behind them. Their origin is not fully understood, some outburst, some violence of birth, that flings dense knots through the nursery at great speed, leaving bright trails to mark their passage. Because all the stars in a nursery are born together, out of one cloud, the place becomes a kind of open record of how stars are made. Every stage of a young star's life is present somewhere in the cloud at once: the barely gathered knot, the glowing protostar, the newly lit sun still wrapped in its disk, so that by moving the eye from one object to the next, we can read the whole sequence of a birth that in any single star would take far longer than a life to watch. Some steps in that sequence are quick, a matter of days or hours, and would be easy to miss. But with so many stars forming side by side, and with instruments tuned to the warmth these young objects give off, rather than to visible light, the chance of catching even the brief steps is good. The nursery is not only a birthplace. It is a lesson in birth, laid out plainly for anyone patient enough to read it. The young stars keep disturbing the cloud around them in ways that show. Where their jets and winds meet the surrounding gas, they drive shock waves, outward ripples of compression that race through the cloud and light up as they travel, heating the gas until it glows. The fast-moving knots carry glowing fronts of shocked material at their tips, where iron and other substances are made to shine. None of this is permanent. It shifts and fades over decades or centuries at most. Brief, colored events in the long, slow life of the cloud. The visible thrashing of stars too young to hold still. To watch a nursery across many years is to watch a scene that genuinely changes, one of the few places in the sky where the ordinary patience of astronomy gives way to something almost like motion. There is an old mystery in these clouds, and its answer is one of the gentler surprises in the history of looking at the sky. Long ago, observers studying the light of such nebulae found a green glow that matched no substance known to them. Every element gives off its own particular colors, like a signature, and this green matched none on file. For a time, it was proposed that the clouds must contain some new element, found nowhere on Earth, present only out there in the dark. The truth turned out stranger and simpler than a new element. The green light came from ordinary oxygen, but oxygen in a thin, charged state that cannot exist in any laboratory on Earth because it requires the near-perfect emptiness of a nebula to survive. Crowd the atoms together as they are crowded in any earthly vessel, and the glow is impossible. Spread them thin enough, across light years of near vacuum, and oxygen shines a green that nothing on our own world can produce. The mysterious element was no element at all. It was a familiar gas, made to do something only the emptiness of space allows. The cloud does not stand alone either. It is part of a larger structure, an immense complex of gas and dust that drapes across a whole constellation, holding other famous shapes within it. Nearby lies a dark, dense pillar of dust, curved into a form that has caught the eye of everyone who has ever seen it, standing black against a red glow behind. Farther out, a great curved arc of gas loops across a broad stretch of sky, the swept-up shell left by the deaths of massive stars long ago. The nursery is a single bright chamber in a much larger structure, one lit room in a darkened house of gas. To stand on a world forming within such a cloud, a world that will not exist for millions of years, yet would be to know a sky unlike any we have. Overhead would hang not the scattered handful of stars we see from Earth, but a crowded field of close, bright young suns, far more numerous and far nearer, burning against curtains of glowing gas that cover a broad span of the heavens. Great swirls of luminous cloud would drape across the sky in soft reds and greens and blues, lit from within by the very stars being born inside them, and the whole would shift, slowly, over ages, as the cloud churned and the young stars cleared their pockets of space. It would be a sky in the act of being made brighter, busier, and more colored than our own quiet night, and destined, like the cloud that held it, to fade in time to something calmer as the nursery blew apart and its stars drifted free. For all their scale and their beauty, these clouds are not permanent. The very stars they make are also their undoing. The light and the winds of the young suns push relentlessly on the surrounding gas, and over time they blow the nursery apart, scattering the cloud that formed them into the space around it. The nearest nursery has already lost much of its original material, and in the long run, it will lose the rest. What will remain is not a glowing cloud, but a loose gathering of stars, drifting slowly apart, the cradle gone, and only the children left a cluster of suns that will spread across the galaxy and, in time, forget they were ever kin. We have drifted through such clouds before, on an earlier night given over to the great structures where stars are born. What is worth carrying away from this visit is the sense of a beginning. Everything else on this tour, the fire worlds and the water worlds, the wanderers and the survivors, the failed stars and the great suns, all of it starts here, in clouds like this one, out of gas, drawn slowly together in the dark. The nursery is where the whole strange catalogue is written, one collapsing knot at a time. And from these places where things are being made, we widen the tour once more, past single stars and single clouds, to whole galaxies, and to the ones among them that have gone strange. We widen the tour now to its largest single objects yet whole galaxies, each a gathering of hundreds of billions of stars. Most galaxies are calm, settled spirals or smooth ellipses, turning slowly through the ages. But among them are galaxies that have gone strange, reshaped by their surroundings, or by ancient collisions, wearing their anomalies openly across spans of 100,000 light-years. If a single world can be unusual, a galaxy can be unusual on a scale 1 billion times larger. Consider first the galaxies that trail tales behind them, like creatures of the sea. A galaxy does not always drift through empty space. The great clusters of galaxies are filled with a thin, hot gas that lies between their members, and a galaxy falling quickly through that cluster feels the gas as a headwind. That wind pushes against the galaxy's own gas and strips it away, pulling it out into long streamers that stretch behind the galaxy as it moves. And in those trailing streamers, something lovely happens. The stripped gas, compressed and disturbed, begins to form new stars, so the tails light up with young suns. The result is a galaxy sailing through its cluster, with glowing tendrils streaming behind it, a shape so like a jellyfish drifting through dark water that the name has stuck. In time, the wind strips such a galaxy of nearly all its gas, and when the gas is gone, it can make no more stars. The jellyfish sails on, but the making of light within it slowly ends. Some galaxies wear a stranger shape still, drawn by a collision rather than a wind. When a small galaxy plunges straight through the center of a larger disk galaxy, it does not shatter it. The stars are so far apart that almost none actually strike one another. Instead, the intruder's gravity sends a ripple outward through the disk, the way a stone dropped into a still pond sends a ring across the water, and that ripple gathers gas and stars into an expanding circle. The result is a galaxy shaped like a great bright wheel, a luminous ring of newborn stars surrounding a quieter center, with the faint spokes of the old disk sometimes still traced between them. Such a ring is a passing thing, as galaxies go. Over hundreds of millions of years, it will spread and soften, and the galaxy will settle back toward an ordinary shape. But for a while, it turns in the dark as a near-perfect wheel of light, the slow, frozen splash of one galaxy falling clean through another. Nearly every galaxy in the sky is being carried away from us. The stretching of space itself pulls the galaxies apart, and their light is reddened by the recession, shifted toward the low end of the spectrum as they go. But a few nearby galaxies do the opposite. Bound closely to us, or falling through a shared cluster, they move toward us instead of away, and their light is shifted the other way toward the blue. One such approaching galaxy is also plowing through the gas of its cluster, shedding a long trail of warm gas as it comes, and it carries older wounds as well, faint streams of stars wound through its outskirts, the scattered remains of smaller galaxies it drew in and swallowed long ago. It is a galaxy coming toward us across the dark, wearing the ghosts of its past meals like threads of loose light. Some galaxies are strange, not for their shape, but for their pace. One distant galaxy makes new stars at a rate our own could never match hundreds of times faster, so that, on average, a new star lights up within it every couple of hours. Because it lies so far away, its light has taken most of the age of the universe to reach us, and we see it not as it is now, but as it was not long after the universe began, when such furious building was more common than it is today. Even by the standards of that early, busy time, this galaxy burns unusually bright, and why it should build stars so quickly is not fully explained. It is a furnace glimpsed across almost the whole history of the universe, still blazing in our sky, though, whatever it has since become, finished happening billions of years ago. There is a quiet strangeness in that, worth pausing on, because it is true of the whole sky and not this galaxy alone. Every galaxy we see not as it is, but as it was, by exactly as many years as its light has taken to cross the space between us. The near ones we see almost current. The far ones we see as they were when the universe was young. So the sky is not a single moment, but a stack of moments, the present of the nearby galaxies, the youth of the distant ones, all layered together into one seeming view. When we look out across the galaxies, we are also looking back through time, seeing each at whatever age its distance assigns it. The furious galaxy blazing in our sky is a portrait of the far past, still arriving. And much of what we call the night is, in the same way, old light from things that have long since changed, or drifted apart, or ended. And some galaxies are strange in their very structure, wearing the marks of collisions long since ended. One galaxy, seen nearly edge-on, wears a broad, dark ring of dust around a bright bulge and hides within it two different populations of stars at once, an old, round central swarm and a flat, orderly disk, threaded together in a way that most likely records a merger long ago completed. Another wears a dark band across one side of its face and holds a stranger secret still. Its inner region and its outer region turn in opposite directions. One part of the galaxy rotates one way, the surrounding part rotates the other. That contrary spin is the fingerprint of a collision of two galaxies that met, merged, and never quite agreed which way the whole should turn, leaving the finished galaxy forever winding against itself. These strange galaxies do more than surprise the eye. They let us study things we could not otherwise reach. The trailing tails of a stripped galaxy trace out the thin, hot gas of the cluster. It is falling through gas far too faint to notice on its own, made visible only by the wake a galaxy carves in it. And the way galaxies move within their clusters, far faster than the light we can see would seem to allow, points to a great deal of unseen mass, holding them in place, the same quiet, invisible material that appears to make up most of every galaxy, felt only by its pull and never by its glow. In watching a galaxy shed its gas, or race through its cluster, or wind against itself after a merger, we are watching the hidden parts of the universe leave their marks on the visible ones. The anomalies are not only strange to look at, they are among the few places where the unseen framework of things briefly shows its hand. What these galaxies teach, gently, is that the calm spiral is not the only way for a galaxy to be. We picture galaxies as serene pinwheels turning in the dark, and many are. But galaxies live among one another. They fall through clusters, they pass and pull, and sometimes merge. And every one of those encounters leaves a mark. A tale of newborn stars. A stream of a swallowed neighbor. A center and an edge that turn against each other. These are not disasters in progress. The collisions that shaped them were slow beyond any watching, unfolded over hundreds of millions of years, and are, for the most part, already finished. What we see is the quiet aftermath, the strange, settled shapes that remain when two great things have met and become one. Nor is our own galaxy exempt from this slow story. It drifts, even now, toward its nearest great neighbor, the two of them falling gently together across the space between them. In some billions of years they will meet, not in any collision a single night could show, but in a merging so slow that it would take far longer than all of human history simply to begin. The stars themselves would almost never touch. They are too far apart, too small against the distances between them. Instead, the two great spirals would pass through and around each other over ages, their shapes drawn out and rewoven, until at last they settled into a single new galaxy, larger and rounder than either had been. Anyone watching from a world within, if the watching could span such time, would see the other galaxy grow slowly in the sky across millions of years until it filled the night and the two skies became one. It is a strange thing to know that our own quiet spiral carries such an ending in its future, and a gentle thing too, for it lies so unimaginably far ahead that it asks nothing of anyone now alive. There is a certain comfort in that, at the scale of galaxies. Even here, among the largest gatherings of stars, the same story holds that we have followed all night, that the unusual is made from the ordinary, by ordinary means, given enough time and the right encounter. A jellyfish galaxy is only a spiral that fell through a headwind. A counter-turning galaxy is only two ordinary galaxies that met. Nothing has been broken. The rules have simply been carried, once again, into a place where they produce something that looks impossible and is not. And having come this far outward from a single world to a whole galaxy, there is only one direction left to go. Outward still, to the largest structures of all, and to the strangest fact the tour has to offer, which is the shape and the story of everything together. We have come a long way outward from a single world, almost like home, through worlds of fire and water, past the wanderers and the survivors, the failed stars and the great suns, the nurseries and the strange galaxies. There is only one direction left to travel, and that is outward still, to the largest structures there are. And here, at the end of the tour, the anomalies stop being objects at all. They become the arrangement of everything, the way the whole universe is put together, and the strange fact that it is put together in any particular way at all. The first thing to know is that the galaxies are not scattered evenly through space. One might expect them to be sprinkled at random, like sand thrown across a floor. They are not. Instead, they gather along immense threads and sheets, strung together in long filaments and broad walls, with enormous near-empty spaces between hollows of darkness where almost nothing lies, some of them stretching hundreds of millions of light-years across, with scarcely a galaxy inside. Seen at the largest scale, the universe looks less like scattered sand and more like a web or a network of bright filaments wrapped around great dark bubbles of emptiness. The galaxies live on the threads. The spaces between the threads are the quietest places that exist. Our own galaxy sits within this web, and its address is a nested one. We belong to a small group of galaxies, which belongs in turn to a larger gathering, which belongs to a single enormous basin of galaxies, a region so large that all the galaxies within it are leaning, very slowly, in the same direction, drawn together toward one part of the sky. We are not still. We are drifting, with everything near us, toward a common place, carried along by the pull of all the mass that lies ahead. And what lies ahead, at the bottom of that long, slow lean, we cannot easily see. It is a concentration of mass great enough to draw whole galaxies toward it, and it happens to sit almost directly behind the bright band of our own galaxy, hidden from us by the very stars and dust of the Milky Way. For a long time it was one of the quieter puzzles of the nearby universe, an enormous pull, plainly felt, whose source lay behind a curtain we could not part. We could measure the drift of the galaxies toward it, and infer the weight required to cause that drift, and yet not look at it directly. It remains a great attraction glimpsed only by its effect, the whole neighborhood of galaxies falling gently toward something we still cannot fully see. Larger still are structures that strain the rules of how the universe should be built. By the simplest and most widely held picture, the universe on the largest scale ought to be smooth, much the same, in every direction, with no single structure allowed to grow past a certain size, because there has not been enough time since the beginning for anything larger to gather. And yet we have found arrangements of galaxies that seem to break that limit, one immense grouping in particular that stretches across a span so great that by that simplest reading it should not exist. Its size sits in open tension, with our best understanding of how structure forms. Whether it is truly a single bound thing, or a chance alignment that only looks like one, is still debated. But taken at face value, it may be the largest single anomaly on this entire tour. A wall of countless galaxies wider than our models are comfortable allowing, a structure whose mere existence is a standing question written across billions of light years. Structures like that sit uneasily beside one of the guiding ideas of how we understand the universe, the expectation that, seen broadly enough, everything should look much the same everywhere, with no region very different from any other, and no single object allowed to grow past a certain scale. A grouping too large unsettles that expectation. If it is real and truly bound together, then either such things can gather faster than we thought, or the universe is a little more uneven on the largest scales than our simplest picture allows. Neither possibility is settled, and neither is any cause for alarm. This is the ordinary way understanding grows, by finding the places where the picture strains and looking harder at them. But it is worth savoring that the largest things we have found are also, in a sense, the least explained, that as the tour reaches its greatest scale, it arrives not at a tidy final answer, but at an open question, a structure so large that its existence is itself the anomaly, quietly waiting for us to understand it. Beyond every structure lies the strangest fact of all, and it is not a thing, but a condition. Space itself is stretching. The distances between the far galaxies are slowly growing, and the most distant of them are receding so quickly, carried on the expansion of space, that their light will never reach us at all. Follow that, stretching forward in the mind, and the sky slowly empties, the far galaxies sliding one by one beyond the reach of any possible sight. Follow it backward instead, and everything draws together closer and hotter and denser until it converges on a single blazing beginning from which all of this unfolded. The universe, then, has an edge not only in distance, but in time. There is a horizon around us, past which we cannot see, not because the dark beyond it is empty, but because light from there has not had long enough, in all the ages of the universe, to cross the space between. What becomes of it all, in the farthest future, is not settled. Perhaps the stretching runs on forever, and the sky thins toward an endless, even quiet. Perhaps it slows and reverses, drawing everything back together. Perhaps every fire simply burns down, one by one, until the whole spreads into a single, even cold. We have spent other nights among these long endings, and there is no need to weigh them again here. What matters tonight is only that all of them are unimaginably far-off stories, measured in numbers so large that the words for them lose their grip, belonging to a future in which nothing we know or love has any stake at all. It is worth dwelling for a moment on the emptiness itself, because the great hollows in the cosmic web are anomalies in their own right. Some of them stretch for hundreds of millions of light years, with almost nothing inside, no bright galaxies, only the faintest scattering of matter and long reaches of near-perfect dark. A traveler set down in the middle of one of these hollows would see a sky nearly bare of stars, the nearest galaxies so far off as to be the dimmest of smudges. They are the quietest, emptiest places the universe contains, and they are not small accidents, but a basic feature of how everything is arranged, the dark counterpart to the bright threads, the hollows around which the whole web is wound. We have spent other nights tracing these arrangements the way our galaxy sits within its group, and its group within larger gatherings, and the whole slowly cast toward that hidden weight beyond the bright band of the Milky Way. What is worth adding here is only how recently and how partially we have come to see it. For most of history, the universe seemed a scattering of separate lights. Only lately have we learned that those lights are strung upon a structure that the galaxies trace out threads and walls and hollows on a scale so large that a single such feature can take light billions of years to cross. The structure was always there. We simply could not stand far enough back to see its shape, and in truth we still cannot. We piece it together, patiently, from the positions and motions of the galaxies within our reach. That is the quiet difficulty of the largest anomalies. They are too big to see whole. A world we can imagine standing upon, a star we can picture hanging in a sky, even a galaxy we can hold, in a photograph, in the palm of the mind. But a structure billions of light years across cannot be seen entire from any place a living thing could ever stand. It can only be assembled, piece by piece, from the small part of it that lies near enough to study a map drawn by a mapmaker who can never climb high enough to look down on the whole of the land. And so we arrive at the deepest anomaly the tour has to offer, which is not the darkest world or the largest wall, but something quieter and stranger than either. It is simply that there is a hole at all. That the same unhurried laws which make a diamond world and a jellyfish galaxy, which strip a planet down to its core and light a nursery of new suns, also gave the entire universe a beginning and a shape and a slow, patient end. Everything we have visited tonight, every strange world and restless star and trailing galaxy, is one small working out of those same few rules, followed into one more unusual place. The anomaly was never a break in the order of things. It was the order of things, seen honestly, all the way to its edges. And so we leave the anomalies where we found them, the world that rains stone, the wanderer with no sun, the wall of galaxies too large to explain all of them, turning quietly in the dark, needing nothing from us, strange and lawful at once. The universe keeps its odd and beautiful corners whether or not anyone is awake to name them, and it has kept them for longer than there have been eyes to look, and it will keep them long after. There is nothing out there tonight that asks anything of you. There is only a great deal of it, turning slowly and very far away. Let your thoughts grow slow. Let the strangeness settle into wonder, and the wonder settle into quiet. Sleep well, and good night.